Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So today in our optics class, we starting our chapter with the topic optical instrument. So in the heading of optical instrument, we have to cover mainly microscope and astronomical telescope. So first we have to cover microscope and then astronomical telescope. Astronomical telescope is of two type. One is reflecting and another one is refracting. Okay, so any one of the microscope or telescope may be asked in your examination. And in that, both the type of telescope, we have to derive the formula for magnifying power. So we have to derive the formula for magnifying power. Yes, so let us start. Okay, first student, power of accommodation. Our first topic is power of accommodation. So what is power of accommodation? The ability of eye to see near object as well as far object is called power of accommodation. Means eye having a capability with the help of ciliary muscles, eye may be thicker or thinner. By the pressure of these ciliary muscles, our crystalline eye lens is able to change its shape. When the lens is thinner, its focal length is high and it can focus the object at large distance. Clear or not clear? Hmm. No, it becomes thin. Okay, the lens becomes thin. The pressure on the ciliary muscles are relaxed. Okay, so the lens becomes thin and it can focus the things which are at a large distance. So this is the first situation. Now, second, when the lens is contracted, so it becomes thicker. Yes, so this is the thicker one lens. Now it is contracted by the excessive pressure of the ciliary muscles. Now the power increases and it can focus the things at very small distance. Clear or not clear? So when focal length is less, the object are nearer from the eye, the focal length of the lens decreases and lens becomes thicker. Lens becomes thicker. Okay, and lens becomes thinner. Here the muscles are relaxed, so focal length increases and lens becomes thinner. Clear, students? So this ability of eye somehow to change its focal length, okay, and it become thinner and thicker, this ability is called power of accommodation. Okay, so ability of a eye lens to change its focal length. Yes, ability of the eye to see the near object as well as the far object. When the object are far, focal length will be more, and when the object are nearer, focal length will be less. Clear? So this ability of a lens is called what? Power of accommodation. So this ability is called power of accommodation. First thing. Now second thing is range of vision. Range of vision, there are two type of range of vision. First, maximum you can see. So for range of vision, for a healthy eye, two types of point are defined for a healthy eye. First is far point. Okay, first is far point. Means a healthy eye can see as much as far. So a healthy eye can see a distance up to infinite. So far point is said to be infinite. Okay, far point is equals to what? Infinite. And near point. What is near point? A near point means, so this, suppose this is the eye, and a near point means a healthy eye can see the clear things at least means the nearer distance The nearest distance an object can be seen very clearly is called the near point for a healthy eye, and for a fresh eye, it is equals to 25 centimeter. Okay, note. So, student, the range of vision, the minimum distance for a clear vision of an object is called least distance of distinct vision. Yes, it is also called what I said near point is for a healthy eye is equals to 25 centimeter. So, LDDV. This is called least distance of distinct vision. Least distance of distinct vision. Clear? And it is equals to how much? 25 centimeter. Means from your eye, if an object is seen clearly, so the minimum distance required to see it clearly, and you can differ between the two bodies with a good contrast. Okay, so this distance has to be 25 centimeter. This is called LDDV. Okay, and in normal symbols, it is denoted by capital D. Okay, LDDV. Far point is equals to infinite. Okay, so far point depends on the size of the body. Like stars are very, very big, very large, and stars can be seen by the human eye without using any aid. They can be seen, so they are supposed to be at infinite distance. Okay, so far point for a healthy eye equals to infinite means a human eye can see the things at a distance infinite. Clear? Okay. Now, next is range of vision. So, we have completed. For a normal eye or healthy eye, the distance is generally taken to be 25 centimeter. Next, very important thing, it is visual angle. What is visual angle? It is also called angle of vision. So, make the definition angle of vision. Clear? Visual angle or angle of vision. Yes, no need to write. Only formula you have to write. Visual angle or angle of vision. The size of the image on the retina is roughly proportional to the angle subtended by the object on the eye. Yes, here this is the object. Now you check please. Here this is the object. This object making an angle theta on the eye. Clear? You can make it roughly like this. This is your eye. Now take a line, central line from eye, and this is your object. Okay. So this object making an angle with the eye, say suppose the name of the angle is alpha made with the okay eye. So this angle alpha is called angle of vision. Okay, angle of vision of the object, or it is this angle is also called visual angle. Technically, this angle, if this is theta, so the same angle having the image because the image will form down retina. Yes, this is the object. The same image will form on retina, and technically the image will form the same angle. The yes, the size of the image of an retina is roughly proportional to the angle subtended by the object on the eye. This is known as visual angle. Clear? Means object and retina will have subtend same angle on the eye. Clear or not clear? So that's why object is nearly proportional to the image. Clear? Next is magnifying power. Yes. In each of the cases, we have to derive the term magnetic magnifying power for different type of microscope or different type of telescope. So what is magnifying power? Magnifying power is the factor by which image on the retina can be enlarged by using the microscope or telescope. Yes. So magnifying power is the factor. Yes, it is the factor. Like Using telescope, you have object like this. This is some planet or anything. Okay. And using microscope, you make it 9 times larger. Clear or not clear? So your magnifying power is small m is equals to 9. Means the factor, it is the factor by which the image on the retina can be enlarged. It is the factor by which the image on the retina can be enlarged by using the microscope or telescope. So by the use of microscope or telescope, you can enlarge your image by a factor. That factor is called magnifying power. The formula for magnifying power is equals to, write this formula, very important. M, magnifying power, equals to visual angle formed by final image divided by visual angle formed by the object kept at D. Yes, very important. This is the main important formula. Visual angle formed by the final image divided by visual angle formed by the object kept at D. Because in microscope, you have to keep the object on the distance D. First, the object should be very clear for your eye. So for the microscope, your in the first situation, your visual angle will be taken when the object has a linear distance of distinct vision. So write this formula very clearly. Magnifying power of a microscope is equals to capital M, visual angle formed by the final image upon visual angle formed by the object kept at D. Clear? Student, D meanings here, least distance of distinct vision. Capital D, as I said here, the symbol for the least distance of distinct vision is equals to capital D. Clear? So the object has to be at least distance of distinct vision. Next is magnifying power of a telescope. So what is magnifying power of telescope? So for telescope, it is impossible that telescopes are used to see the long distances object. So like this is a telescope and it is used to see the heavenly planets or astronomical bodies at very large distance. So it is not possible because they are very large distances. Just 1 second, beta. So students, the objects for the case of telescope are at a very large distance, like there are millions kilometer. So you can't place your object like this is a planet on the least distance of distinct vision. So the formula will be changed here for a magnifying power of a telescope. Magnifying power for a telescope M is equals to visual angle formed by the final image divided by visual angle formed by the object. Okay, write this formula, visual angle formed by the final image divided by visual angle formed by the object. Okay, so next now we starting the chapter topic optical instruments. So first topic is microscope. We have to cover microscope and telescope. So what is microscope? We should know the definition of microscope and telescope. So what is microscope? It is an instrument used to see very small object. Yes, like in our biology laboratory, we using the microscope. So this is the device used to see very small object. Okay, so the microscope will give a magnification to your object and you will have a magnified image. Okay, so in that microscope you have to find the magnifying power. So later on we will find the magnifying power of a microscope. Microscope are the two types. One is called simple microscope, that is our simple magnifying glass. We have played with this glass in our childhood. Okay, we have a magnifying glass. Generally, we burn the paper using of this glass. And second is compound microscope. Clear? Now, for the telescope, we have the two type of telescope. One is refracting telescope and another is reflecting. So, by the name reflecting telescope, will use a mirror. Okay. Yes, make this chart. So, student, we starting simple microscope. Okay. So what is a simple microscope? Simple microscope is used for observing the magnified images of the object. Yes, it is used to see the magnified images of the object. It consists of a converging lens of a small focal length. So this microscope is used to see the object usually at a small distance, because this microscope is using a convex lens of low focal length. Clear? So here we have a convex lens of low focal length. In that we have an object. See here, this is the object, and this object making an angle theta, theta. So you have to take the object between focal length and focal length and pole, sorry, optical center. So for a convex lens you will have a erect and virtual image that is equals to h dash. Clear or not? Yes. See this. So it is used to observing magnified images of the object. It consists of a converging lens of a small focal length. Now angle subtended by the object. So first here h, your object is of height h. Okay. Remember, for a microscope, visual angle formed by the object kept at d. So you have to take the object by normal adjustment, like when you have a hand lens. So you adjust your object to make its clear image. Yes or no? You make it up and down by just moving it above the some object. Yes or no? So you have to take the object at a least distance of distinct vision. So here m is equals to visual angle formed by image divided by visual angle by object kept at a distance d. So write this magnifying power. M equals to visual angle formed by the image divided by visual angle formed by the object kept at d. Clear? So you have two angles. First angle is for the object. Remember, the two situations are there. First angle is for the object. So we have derived here m is equals to theta by theta naught. Okay. What is theta? Theta is the visual angle for image. Visual angle for image divided by theta naught is equals to visual angle for object kept d at d. Clear? So theta is very small. So for a small theta, this is equals to tan theta. So we have the formula for magnifying power. M is equals to tan theta divided by tan theta naught. Clear? So this is equals to tan theta divided by tan theta naught. Now tan theta equals to how much? Tan theta is equals to perpendicular upon base. Hmm. So tan theta. Now theta is for what? You seen that for theta naught, tan theta naught, you can write tan theta naught equal to perpendicular upon base. So perpendicular of the object here is equals to h, and base equals to least distance of distinct vision. So it is equals to h upon d. Clear or not clear? Now come to this diagram. You see, you will have a image of h dash, okay, of the object h. So this one is the object. You will have an image of h dash, and h dash will make angle is equals to theta. Clear or not clear? H dash will make angle equals to theta. So first tan theta is equals to, for this angle theta, tan theta is equals to perpendicular upon base. Tan theta is equals to perpendicular upon base. So it will be equals to h by u. Why? Because the theta is exactly made with the same angle theta will be made by object as well as image. Clear? Yes, same angle because both the triangles are similar. Okay, so both the angles will be same. So now place the value here. Tan theta upon tan theta is equals to h upon u. Here tan theta is equals to h upon u. So this will be equals to h upon u. And tan theta not equals to h upon d, least distance of distinct division. Clear or not clear? So both h and h get cancelled out and this becomes d by u. So magnification for the magnifying glass, simple magnifying glass or simple convex lens, this is equals to d by u. Put the values here, it is equals to d by u. Done. Okay, so referring the detailed theory of this simple microscope, let us read it. A simple microscope consists of a converging lens of the small focal length. Yes, we have used as a magnifying glass. So it can focus the very short distance object. So obviously it is a very small focal length convex lens, right? A small focal length, a virtual erect and a magnified image of the object is formed at the least distance of distinct vision. Remember, a virtual erect and magnified image of the object is formed at the least distance of distinct vision from the eye held close to the lens. So in the first situation, yes, these lines are very important. A virtual, erect, and magnified image of the object is formed at a distance of least distance at distinct vision. So when you adjusting your lens, yes, try to understand when you are adjusting your lens, then you are not like you having a lens like this, and there is the object, and this is your eye, right? And you focusing the object and try to see the object, but you can't see this object. Actually, the thing you see is the image of the object. The thing you see is the image of the object. So by some adjustment, you try to bring the image at LDDV. Okay, so must note this thing. Image should be at LDDV. Okay, your image should be at least distance of distinct vision. Clear? So a virtual erect and magnified image of object is formed at a least distance of distinct vision from the eye hole close to lens. That is why simple microscope is also called magnifying glass. Clear or not clear? Okay. Here I am using two angles. First angle is made for the eye. Okay. First angle is made for the eye. That is, I am saying alpha. And second angle made by the image, that I am saying beta. So two angles I am going to take here. In the place of theta, I used to take beta, and in the case for theta naught, I have to take alpha for this proper derivation. So there is something changed now. M becomes 10 beta upon 10 alpha. Okay. Yes. So what is 10 beta? 10 beta is the angle of vision made by the image at LDDV, and 10 alpha is the angle made by the object. Clear? Now, starting with a consideration, let us an object AB is held between optical center and principal focus. So here we have the object, our object, this is equals to AB, and for a proper magnification this object has to be placed between optical center and focus. Clear? Yes. F of the lens perpendicular to the principal axis. Obviously a virtual erect so this is what, this is the our u. Okay, this is our u. Let an object AB is held between optical center and principal focus of the lens perpendicular to the principal axis. A virtual erect and magnified image A dash B dash formed as traced in figure. The eye is held close to the lens and CB dash equals to D. Yes. Now our image is formed at A dash B dash. This is our image, right, beta? This is our image. By adjustment, you have to adjust your eye because lens is fixed and your image is fixed. So you have to adjust your eye with respect to lens, and then you will have a fine image of this object at distance t. This is called LDDV. Clear? This is your final image. Now, magnifying power of a simple microscope is defined as the ratio of the angle subtended by the image and the object on the eye. So what is the ratio? Angle subtended by the image means m is equals to first angle subtended by the image is equals to beta, and second angle made by the object, that becomes alpha. Clear or not? Which है ना, and by the on the and the object on the eye, yes, when both are at the least distance of distinct vision. Yes, image is also on the LDDV, and you have to keep your object is also on the LDDV. Clear? When both the distances are at least distance of distinct vision, means both you have to take on LDDV. Clear? Cannot clear? Hmm. So this is what angle of vision of image, angle of vision of image at LDDV, and angle of vision of object at LDDV. Clear, beta? So both the object and image we have to take at LDDV, right? Now let A dash C dash B dash equals to beta. This is most important diagram. A dash C dash B dash. Check here. First I am talking about the angle made by the image. So what is our image? Our image is A dash B dash. Check what angle A dash B dash forming on the eye. So this is the central part of the eye, right? This is B dash. So a line is here from B dash, and a line is here. This is from A dash. So definitely this angle is equals to beta. This bigger angle is beta. Yes or no? So this is equals to beta. Now A dash C B dash equals to beta. What is angle? A dash C B dash. From the diagram, A dash C B dash equals to beta. Clear? And your object should be placed at least distance of distinct vision. So remember one consideration you have to made here. See, previously your object without any adjustment, your object is here without any adjustment, right? Means first time you have keep your lens in front of object, in front of object, your object is here, right? But in this situation it is not necessary that it will form a clear sharp image. So you will move this object somehow closer or far away, so this will form a clear image, and this is called LDDV for this object. Okay, so you have moved, check here, you have to also move your object at a position of LDDV. So you just move it backside and bring it here at a distance of 25 centimeter. So this is the capital D and becomes LDDV. Now check the angle, check the angle here made by this object. So your object, previously your object was AB. Yes, listen all the things very carefully. Previously your object was AB. It was here. Now you shifted your object from here to here. So it will become A1B dash, A1B dash. Clear or not clear? So now your object at a distance of least distance of distinct vision, and this object is making an angle alpha. This is the smaller one angle. Clear or not clear? So beta is the larger one and alpha is the smaller one. So A1, what I said, A1 C B dash equals to alpha. So A1 C B dash equals to alpha. Clear? Now magnifying power, M is equals to beta upon alpha, as the angles are very small. So I can consider them as 10 beta upon 10 alpha. Now place the values here. Hmm. Place the values. 10 beta is equals to perpendicular upon base. So it is equals to AB upon CB. Yes. Here see perpendicular upon base. For alpha, 10 beta. This complete angle is equals to 10 beta. So it is equals to AB upon BC. Clear? And 10 alpha is equals to A dash B dash. 10 beta is equals to AB upon BC. No problem. Okay. And 10 alpha, this is equals to 10 beta. And 10 alpha is equals to, it will be what? Perpendicular A dash B dash, A dash B dash, right? Upon B dash C for alpha. Yes or no? B dash C. Clear or not clear? Okay, so 10 beta is equals to AB upon CB or BC, and 10 alpha is equals to A dash B dash upon CB dash. Okay, and A dash B dash is parallel side for this, so it will be equal because you have just slide this. So A dash B dash equals to AB. Yes or no? So in the place of A dash B dash, you can write AB, arm of the rectangle. Yes or no? Opposite side of rectangles are equal, na? Clear? So in the place of A dash B dash, you can put here AB and this becomes AB upon B dash C because A dash B dash is equal to AB. Clear? Hmm. So now put here, now place the values here. 10 beta is equals to AB upon CB upon 10 alpha. So it will uh, reciprocal. Okay, coming upside, CB dash upon AB. Yes, CB dash upon AB. AB to AB cancel. This is equals to CB dash upon CB. Clear? Now, what is CB dash? From center to image. CB dash. Okay, center to image, it is become minus of V. And CB becomes what? U. So, the formula for magnification becomes M equals to V by U. Clear or not clear? So M equals to V by U. Note it down. M equals to. So we have got the relation M equals to V by U. Okay. M equals to 10 beta upon 10 alpha equals to V upon U. As we know that V is equals to capital D, least distance of distinct vision, where your final image was formed. Check in the diagram, V is equals to D. Yes, here the final image is formed and this is V and equals to D. Yes or no? So we have placed the value of D in the place of V. So you have the relation M is equals to D by U. So this is first formula for magnifying power. M is equals to D by U for simple microscope. Clear? So this is the first formula. We have also derived it here. M equals to D by U. Clear? Hmm. Now two cases are arising there. For the magnification, two special cases are there. One is called maximum magnification and second is called minimum magnification. Okay. One case is for maximum magnification and another is for minimum magnification. Okay. This is the value of magnification in the terms of D, but in the terms of F, is small f, there are two cases. One is for maximum magnification and one for minimum magnification. Understood? Okay, so let us derive this one. How can you derive this one? So using lens formula, you have what? So from here, you have to write please, using lens formula. So using lens formula, we know that 1 upon f equals to, for lens, is equals to 1 upon v minus 1 upon u. Clear? 1 upon V minus 1 upon U. Throughout multiply D both the side. Multiply D both the side. So if we multiply D both the side, we have D upon F equals to D upon V minus D upon U. Clear? D upon F equals to D upon V minus D upon U. Hmm. So D upon U is equals to what? D upon U is equals to M. D upon U equals to M. Clear? So in the place of D upon U, I can put here D upon F is equals to, oh, check it once again. For using Lenz's formula, we have the formula 1 upon F equal to 1 upon V minus 1 upon U. So if I multiplied it and the numerator D, so it is becomes D upon F equals to D upon V minus D upon U. D upon F equals to D upon V minus D upon U. So make it D upon V minus D upon U. The value of D upon U is equals to what? M, magnification. Yes or no? So M. So make it right side, left side, sorry. So M equals to D upon V minus D upon F. Yes or no? So it's become D upon V and minus D upon F. Yes, make one more attempt. Take from the using Lenz's formula. We have a formula Lenz 1 upon F equal to 1 upon V minus 1 upon U. Okay. So using Lenz's formula 1 upon F equals to 1 upon V minus 1 upon U. Okay. And we have to make it V by U. Yes. Our choice is equals to V by U. Later on, in the place of V, I can place here minus D. So first make V by U. So you have to multiply it by V, multiplying both the side by V. Okay, not by multiplying both the side by D. So by multiplying both the side V, it will become V upon F equals to V upon V minus V upon U. Okay. So V upon F equals to 1 minus V by U. Clear? Now V by U, we just derive that V by U here. V by U is equals to magnification. Clear? So V by U is equals to magnification. So V by F is equals to 1 minus magnification M. Make it M part is here. So M equals to 1 minus V by F. Clear? Now M equals to 1 minus V by F. As we know, V equals to minus D. V equals to minus D. So place here the value M equals to 1 minus of D by F. So it become M equals to 1 plus D by F. Clear? Yes, M equals to 1 plus D. Okay, students. So we have derived this one case with the name maximum magnification. So when image is formed at D, that is least distance of distinct vision, so U becomes minus U and V becomes minus D. Okay, and F equals to positive F. So by the formula, we got M equals to 1 plus D by F. Clear? Done. Okay, next case is minimum magnification. So minimum magnification, you should have a image as a point object. And you know, when your object, when image is formed at infinity, sorry, for minimum magnification, your object should be formed at infinity. Okay. So for minimum magnification, your image has to be formed at infinity. So you have the formula M is equals to D upon U, V upon U, sorry. M is equals to what? V upon U. We have derived the formula here. M is equals to D upon U. First we have V by U and we have made it D upon U. Okay. M equals to D by U. M equals to d upon u. Now, when final image formed at infinity, then what? U should be equals to focus. When your object is at focus, your image will be at infinity. Yes or no? When your object is at focus, yes, like your object is here on the focus, you will have your image at infinite. Yes or no? So you have to place here Fe or F. So M is equals to D upon F. So this is the value for minimum magnification. M is equals to D by F. Clear? So M infinite, this case is written as M infinite is equals to D by F. Clear? Hmm. You can also develop this case by this rule, 1 upon f equal to 1 upon v minus 1 upon u. Alternatively, you can do it like this. You have the formula, length formula, 1 upon f equals to 1 upon v minus 1 upon u. Clear? This is the normal formula. Now, 1 upon f equals to, for infinite, if your image is formed at infinity, then you have to place v is equals to minus infinity, sorry, infinity only, minus 1 upon u. As the u is on negative side, so you have to place it minus u. So 1 upon f equals to, this becomes 0, minus 1 upon u. Clear or not clear? So 1 upon f is equals to 1 upon u. By cross multiply, you will have u is equals to f. I have directly put it here, u is equals to f, fe, focal length. Clear? So by directly, you have the same formula, d upon f. Otherwise, by this, now come to the magnification formula. You have the magnification formula, m is equals to d by u, d by u. So you place the value here. So m becomes d by f. Clear? So this is the magnification for the infinite case. So more better you write it m infinite. Okay. So m infinite equals to d by f. Clear? So two cases are there. M infinite is equals to d by f. This is minimum magnification, and maximum magnification equals to 1 plus d by f. So remember these two formulas. What is minimum magnification? For infinity, this is equals to d upon f. And what is maximum magnification? This will be carried out when your final image is at least distance of distinct vision. This is equals to 1 plus d by f. Okay. Two formulas are there. Make it. Write it. By the observation of formula, we have the formula m is equals to d by f plus 1. Okay. So as focal length decreases, if this is decreases, then magnification, this term will be increases. So m is increases, that is smaller the focal length of the lens, greater is the magnifying power. Clear or not clear? Yes, we have the two formulas. For infinity, it is equals to d by f only. So smaller will be the focal length, maximum will be the magnifying power. Clear? Means for a good magnifying lens, you have it's a smaller focal length. Okay, next topic is students, compound microscope. Yeah, this is sure for exam because only two derivations are there in our syllabus. One is for compound microscope and second is astronomical telescope. So every year or alternatively year, this has been asked in your examination. What is compound microscope? Actually, this lens, magnifying lens, is of very short focal length, okay, and give you a limited magnification, very small amount of magnification, like 10% to 20%. Clear? But if you want more magnification, very small bacteria size elements are there, so you have to need of magnifying power up to a greater extent. So a compound microscope that consists of two lenses. Okay, in compound microscope you will have two lenses. One lens is that is near to object, that is called objective lens. That is near to your bacteria slide is called objective lens. Clear? And one lens that is near to your eye is called eyepiece. Maybe you have worked on the compound microscope and you're a biology student, so surely there will there is a slide is there. Okay, so one lens is in this barrel. This is objective. Okay, and another lens that is very close to your eye somehow here is called eyepiece. So there are all total two lenses. Clear or not? So a compound microscope consists of two converging lens means convex lenses as an objective lens O is of very small focal length. Yes, because it is very closer to the slide. So it having very small focal length. F is very small. Clear? And this is called objective lens. Focal length of the objective lens is called FO. And relatively, and the focal length and short aperture. Its aperture is also very small. And an eyepiece E of a moderate focal length or somehow larger focal length and is of large aperture. So two lenses are there. Understood everything? Yes. So the two lenses are held coaxially at the free end of a tube at a suitable fixed distance from each other. The distance of the objective lens from the object can be adjusted by rack and pinion arrangement. If you already have worked with a microscope, then you know this like arrangement is there between objective and eyepiece. Here the objective lens is placed, right? And here the eyepiece lens is placed. This is E, this is O, and this tube is movable under this tube. This the larger one tube. The smaller tube is movable under the larger one tube. Yes or no? Have you moved it during your experiment? Have you moved it? Yes. So this is called rack and pinion arrangement. Okay. So only name is good. This is called rack and pinion arrangement. Means the arrangement by that you can move the one tube over the another or under the another. That is called rack and pinion arrangement. Clear? And length of both the tube. So this is the length of larger tube and this is the length of a smaller tube and this is called total length. Okay, so L length of the total tube is equals to length of objective tube plus length of eyepiece tube. Clear? Actually, two lengths are there. This bigger one and this smaller one. Yes or no? So this is called length of tube. Clear? Hmm. The, okay, done here. Now make a ray diagram, very clear ray diagram. This should be very clear. Now, how to make this ray diagram? First, you have your object AB. Make object AB. Okay, and this is your object. It is beyond focus. Obviously, it has to be beyond focus, or otherwise, it will make a virtual image. So, when your object is beyond the focus, it will make your real and inverted image like here. Real and inverted image A dash B dash. Clear? Hmm. So here your object it will make a real and inverted image. This is A dash B dash. Now place your eyepiece in such a way that this real image made by the objective lens lie between focus and center of curvature of the eyepiece. Okay? Not center of curvature, optical center. What I said? Place your eye lens such that the image formed by the first lens, this one, A dash B dash. Okay. This A dash B dash falls between eyepiece focus, means the second lens focus, and its center of curvature. And you know, when the object is formed between focus and optical center, it will have its virtual image. Yes or no? So first ray that is coming from this lens going this side and the second ray coming from this side going this side. So they are having divergent in the forward direction. So make them converge and you will have your final image here. Understood or not? This is your final image A1 and A double dash. Clear or not clear? This is your final image. Okay, clear? Hmm. So this is the ray diagram. Now, first object distance is u, object distance is u, and your final image is formed at least distance of distinct vision. So this is VE, and VE becomes D, means distance by eyepiece becomes equals to D. Clear? Now take the angles. What is angle of vision? Angle of vision for image. So this is your final image, A dash. So A dash making an angle beta. Yes, so make it extend backside, and this is your angle beta. Clear or not? Hmm. Where is alpha? What is alpha? Alpha is the angle made by the object. So here it is your object. Okay. Here it is your object. Yes or no? So what is alpha? Alpha is the angle of vision made by the object keep at least distance of distinct vision. Yes, here we have written the formula. What is angle of vision of image beta and angle of vision of object, okay, kept at LDDV. So first this is your object. Now slide it here and bring it on A1 B double dash. Now take the angle made by this. This angle is equals to alpha. Is it clear? This angle is equals to alpha. So we have all the things. We have alpha, we have beta. Alpha is the angle made by the object at LDDV. Beta is the angle made by the image at LDDV. Okay. What we have done, the image formed by the objective lens, keep the image formed by the objective lens between optical center and eyepiece, focus of the eyepiece. So it will give its virtual image. Okay. And larger image. Clear or not? Yes. So read it theory. First, we are going to read the theory, then after making the diagram. Let AB is the tiny object held perpendicular to the principal axis. Yes, this is the very small object. Like bacteria slide, we have placed it front of the objective lens. Principal axis in the front of objective lens. Beyond its principal focus FO. Yes, it has to be beyond its principal focus FO. So it can make its real image. This image has to be real. Okay. A real inverted and enlarged image A dash B dash. Okay. So beyond the focus, the object will made its real, inverted, and somewhat uh, larger image. Okay, somewhat enlarged image, and that is A dash B dash. So A dash B dash image is formed of the object of this object formed by the objective lens. Clear? Now A dash B dash is works like our object for the eyepiece. Now A dash B dash acts as an object for the eye lens whose position is so adjusted that A dash B dash lies between optical center C2 of the eye lens and its principal focus. Okay. So make the adjustment in such a way that this A dash B dash is lying between C2 means optical center C2 and focus FE, principal focus or FE. So a virtual and magnified image A double dash B double dash is formed by the eye lens. So check here. Here the virtual and magnified image. This is A double dash and B double dash. This is the final image formed by the eyepiece, eye lens. Clear or not clear? This image is erect with respect to A dash B dash. Yes, you see this image, the final image is erect with respect to A dash B dash because the orientation of A dash B dash is downside, and in the same way the orientation of A double dash B double dash is downside. But with respect to object, the final image is inverted. Yes or no? Because the object is on the upward direction, so B here and A here. So your final image is inverted. Okay, so the image is erect with respect to A dash B dash, but it is inverted with respect to AB. The final image A double dash B double dash is seen by the eye close to the eye lens, the adjustment are so made that A double dash B dash is at the least distance of distinct vision from the eye lens. So C2 B double dash equals to D. Where is C2 B double dash? Yes, as I said, this is C2 and this is B double dash, and the distance between the final image and the optical center should have D. Clear? The final image should be formed at least distance of distinct vision. Clear? Clear? Okay. Talking about magnifying power of a compound microscope is defined as the ratio of the angle subtended by the eye lens of final image. Yes, this is means beta to the angle subtended by the eye lens of the eye lens by the object when both the final image and the object are situated at least distance of distinct vision for the eye means beta upon alpha. So magnifying power becomes m equals to beta upon alpha. Yes, we have discussed both the angles beta and alpha. Yes, sir. In the diagram, we talked about this. Okay, students. Any problem related to beta and alpha? Beta is clear. Where is beta? This is beta, the angle made by the image. Where is alpha? This one, the smaller one is alpha. Yes. Clear or not? The upper one, this one angle is equals to alpha. So you have to place m equals to beta upon alpha. Now, as the angles are small, so alpha becomes 10 alpha and beta becomes 10 beta. So it is equals to 10 beta upon 10 alpha. Now see the diagram. So first you have to make the diagram. Then after I am talking about the values of it. So students, 10 beta upon 10 alpha. Now check what is 10 beta. 10 beta is equal to perpendicular upon base for the final image. So check for the diagram. It is equals to A double dash B double dash upon C2 B dash. Yes or no? It is equals to A double dash B double dash upon C2 B dash. Perpendicular A double dash B double dash. And base equals to this one C2 B dash. Clear? Now alpha 10 alpha is equals to perpendicular A dash B double dash upon perpendicular here equals to A dash B dash upon B double dash C2 or C2 B double dash. Okay. So check here. It is equals to perpendicular AB upon C2 B double dash. Now place the values here. So M is equals to 10 beta upon 10 alpha. So this is equals to 10 beta and this reverses. So you will have C2 B double dash upon AB. Now C2 B double dash and C2 B double dash cancel each other and you will have A double dash B double dash upon AB. Okay. Now you have to do some alteration here, right? You can write like A double dash B double dash upon 1 into 1 upon AB. Clear or not? Because this is on numerator and this is on denominator. So we just place the value A here. Now, could you multiply here AB and AB? Sorry, A dash B dash and A dash B dash both the side? By multiplying A dash B dash, they cancel each other. So there will be no effect on the relation. Yes or no? So you can multiply it by A dash B dash into A dash B dash numerator and denominator. Now check what is A dash B dash. A double dash B dash double dash upon AB. This is magnification produced by eye lens. Because what is M? Magnification for the lens equals to height of the image upon height of the object. So A double dash B double dash is the height of image for the eye lens. And this is height of object for the eye lens. Yes or no? So this becomes magnification for the eye lens and this becomes magnification for the objective lens. Yes or no? Okay. So we have final magnification M equals to ME into MO. Yes. So we are moving with the compound microscope. Compound microscope. And we have the derivation M equals to ME multiplied by MO. Okay. So ME multiplied by MO, this formula for M, where ME is the magnification by eye lens and MO is the magnification for objective lens. Okay. Now for we know we have the formula ME is equals to 1 plus D by FE. From where it came? It came from magnification by the simple magnifying glass. So we have the formula ME is equals to 1 plus D by FE. Yes or no? ME is equals to 1 plus D by FE from the simple microscope. Okay. From simple microscope, we have the formula magnification for any lens M for eyepiece equals to 1 plus D by FE. We have derived it. Clear or not? Where D is the C2B double dash is the least distance of distinct vision and FE is the focal length of the eye lens. Now MO, now place the value of MO here. So M is equals to what? We have derived M is equals to 1 plus a small d upon Fe. Now MO means magnification of the objective lens. This should be VO. MO is equals to, for lens, you know, M equals to V upon U. So this is equals to VO by UO. Yes or no? It may be VO upon UO. So place here it is equals to VO upon UO. So final derivation becomes VO upon UO 1 plus a small d by Fe. Okay. So yes, but UO should be negative. Yes, because the distance towards the object has to be negative. So it is equals to minus VO upon UO 1 plus D by FE. This derivation 1 plus D by FE. Clear or not? Okay. Hmm. Now, length of the microscopic tube. By the diagram, length of the microscopic tube you can found here. Yes, you can find here length of the microscopic tube. Check the length of the microscopic tube. This is the image formed by the objective lens. So it is said to be VO here. Up to here, it is what? This is the image formed by the objective lens. Yes or no? VO. And this is what? This is said to be UE because this distance is the distance of object from the eyepiece. So the lens length becomes VO plus UE. Yes or no? So length of the microscopic tube becomes VO plus UE. Clear? So two derivations are here. Magnification M is equals to minus M V naught upon U naught 1 plus D by FE and L equals to VO plus UE. So student, we have got here the length of the tube equals to VU upon UE. Now you know this objective lens for a compound microscope is very closer to the object, means uh, and it should beyond the focal length of the objective lens. This means this distance UO is near about FO. UO equals to C1B. Yes, you can see your diagram. UO equal to C1B. C1B is the distance of object. This is C1 and this is B. So this is called what? UO. Okay, and this UO is very nearer to FO. So UO is nearly about to FO. Okay, so we can place the value in the place of UO. I can put here FO. Okay, so the object AB is lies very close to FO. Therefore, UO becomes C1B is near about C1FO. It is equals to FO. So as A dash B dash is formed very close to the eye lens, then VO equals to C1 B dash, that is equals to C1 C2. This is equals to L. Okay. So now check from the diagram. When your final image is, this is your, yes, this is your eyepiece. Now consider the image made by the first lens, which is very close to your eye lens. Okay. Hmm. So this distance VO becomes what? This whole work as the length of the tube. Yes or no? Because it is very close to eye lens. So this VO becomes L. So VO equals to C1 B dash equal to C1 C2 is near about L, that is equals to length of the microscopic tube. So this formula becomes M equals to minus VO upon UO. Mm, M equals to minus VO upon UO 1 plus D by FE. Okay, so what we can write here? So VO becomes FO. So this is equals to minus of FO. Okay. No. VO. VO becomes L, UO becomes FO. Okay, so minus L upon FO 1 plus D by FE. This will be your final magnification. Yes, so check here. So it is equals to M is equals to L upon FO minus L upon FO 1 plus D by FE, and this is your final formula. If you considering only this minus sign showing that your final image will be inverted the original one. Okay, this minus sign showing that final image is inverted with respect to the your object, and magnitude you can take L upon FO 1 plus D by FE. As magnifying power m is negative, the image seen in the microscope scope is always inverted. Yes, as your negative sign comes here, this means your final image you see in eyepiece will be inverted. For large magnifying power, FO and FE both have to be small. Yes. For large magnifying power, the denominator should be less. So you will have a small FO as well as you will have a small FE. Okay. Also, FE is taken is smaller than the FE, means the value of FO should be smaller than FE. That is obvious because the slide is very nearer to the objective lens. So this has to be very small. FO should be very small comparable to FE so that the field of view may be increased. Done. Student, notice one more thing is here. It may asks somewhere. So M is equals to, we have calculated the value of M in, in intermediate relation. M is equals to A dash B dash upon AB into A double dash double dash upon A dash B dash. Clear or not? So what is this A dash B dash? This is equals to VO, distance by the objective lens, and this is distance for the objective lens, distance of object. Clear or not? V upon U. And what is A double dash B double dash? It is equals to minus D. A double dash B double dash equals to minus D, and this is A dash B dash equals to minus of UE. So you can cancel it, and you will have the relation M equals to VO upon UO and D upon UE. So make one more line. M equals to VO upon UO into D by UE. Clear? One more formula. It is called M equals to MO upon into ME. Yes, we have derived this one, MO into ME. Uh, yes, here it is equals to ME into MO or MO into ME, but it can be written in the form of what? VO upon UO into D upon FE. Okay, a question may be asked by this formula also. This one, done. Okay, now condition for maximum magnification and minimum magnification. Student, we just have proved the condition for maximum magnification. M equals to VO upon UO 1 plus D by FE. Yes. This is the condition for maximum magnification. M is equals to minus VO upon UO 1 plus D by FE. Okay, because here your final image will formed at the least distance of distinct vision, and you will be given maximum magnification. Okay, minus sign will show that the final image will be inverted with respect to original. So minus VO upon UO 1 plus D by FE. Okay. Second case, make a second case for minimum magnification. Minimum magnification. Okay, minimum magnification will be carried out when your final image will be formed at infinity. Okay, so we have the formula 1 upon F equals to 1 upon V minus 1 upon U. Clear? And for magnification, you have it is equals to VO upon UO into D upon UE. Clear or not clear? Hmm. So for maximum magnification, minimum magnification, your final image will be at infinity. So for focal length, it is equals to focal length of eyepiece and FE, and it is equals to 1 upon minus of UE, that will be negative. So 1 upon FE equals to, this becomes 0, minus minus become cancel, 1 upon UE. So UE is equals to FE. Okay. So here in the place of UE, you can put FE. So M infinite equals to V naught upon U naught into D upon FE. Clear ki not clear? So M infinite equals to V naught upon U naught into D upon Fe. Let me check. Yes, M infinite equals to V naught upon U naught into D upon infinity. So this is the case for minimum magnification. Clear? Okay, write it. Okay, students. Now our topic is astronomical telescope. Astronomical telescope is also called refracting telescope. Okay, refracting, because the two lenses are there and refraction will takes place. So this is called refracting telescope. An astronomical telescope is an optical instrument which is used for observing distinct images of heavenly bodies like planet, etc. Okay, so you can't expect here that your object has to be on least distance of distinct vision, because light rays from infinity will come to the lens and you will have to make their sharper image at least distance of distinct vision. Clear or not clear? Your final image has to be at least distance of distinct vision. But for object, you can you can't expect. Okay. So it consists of a two lenses. The objective lens, that is actually used to gather all the lights. Okay, which is at large focal length. Yes, because it has to focus the large distances object like planet and all. Okay, so the focal length should have very large focal length and the large aperture also. That's why it can gather most of the light. Okay, and give you a brighter image. Yes, and eye lens, which is a small focal length and a small aperture. Okay, eye lens having a small focal length as well as a small aperture. Clear or not? Yes. Now, the two lenses are mounted coaxially at their free ends. So the two lenses are mounted coaxially at their free ends with the two tubes. Okay, like one of is big tube and one is the smaller one tube, and they are arranged with a rack and pinion arrangement. Like some movable bearings will be here, and this tube can be moved. And the distance between the lens can be adjusted using a rack and pinion arrangement. Yes, now the two types of arrangements are there. One is for maximum magnification, that is called M at D, and second is called minimum magnification. So first we are talking about normal adjustment. Okay, normal adjustment. So what is in normal adjustment? So this is normal adjust means minimum magnification, infinity wala, that infinity one. Let a parallel beam of light from an astronomical object at infinity is made to fall on the objective lens of the telescope. It forms a real inverted and diminished image A dash B dash of the object. Yes. See here, this these are the rays. Now, this is angle of vision for the object equals to alpha. So same angle will be here. This is also alpha by vertically opposite angle. Say yes or no. These rays are, as these rays are coming from infinity, so they will be focused at a point, but this point is not said to be focus. This point is said to be on a focal plane. So what is focal plane? Like this is a point of focus. So this is a point of focus. An imaginary plane that is passing through the focus, containing the point of focus, is called focal plane. Okay. So now the lines are refracting at some point on the focal plane. Understood? So here is the point on the focal plane. This point is A dash B dash. Clear? This point is A dash B dash. The eyepiece is so adjusted. Yes, we are talking about normal adjustment. The eyepiece is so adjusted that AB just lie on the focus. So when your A dash B dash lying on the focus, you know When your object is lying on the focus, then what will happen? The rays are coming from the focus are getting parallel and they will never intersect each other, and your final image will be formed on infinity. Clear or not clear? So here the our object, that object on the focal plane by the first lens is made to situated on the focus of the eyepiece. So the rays are going like this and they are parallel, so never intersect each other, and your final image will be formed at infinity. Yes. So the eyepiece is so adjusted that the A dash B dash lie just on the focus of the eyepiece. Therefore, finally, a highly magnified image is formed at infinity. The final image is erect with respect to AB and it is inverted with respect to object. Yes. With respect to, therefore, a finally highly image is formed infinity. The final image is erect with respect to A dash B dash. Yes, this is A dash B dash. And you will have your virtual image. So with respect to A dash B dash, your image will be erect. But with respect to your original object, your final image will be inverted. Why? You getting the reflections, you getting the magnification of the inverted object. Okay. So it has already inverted. So you will have the inverted image of this one at somewhere at infinity. This is called fine normal adjustment. Yes. Okay, fine. Yes. Magnifying power of an astronomical telescope in normal adjustment is defined as the ratio of the angle subtended at the eye by the final image to the angle subtended at the eye by the object. Similarly, that's the 10 beta upon 10 alpha. The same line is there. Okay, directly. So when the final image of the object both lie on infinite distance from the eye. Yes, when the final image and the object both are lie on the infinite distance from the eye. As the object lies at a very huge distance, therefore angle subtended by the object C2 is almost the same as the angle subtended by the object at C1. Because C1 is very close to C2, let it A C1 B dash equals to alpha. Okay, so if this angle is alpha, so this angle is also alpha. Yes, clear or not clear? So so rays coming, so A C1 B dash. So we are talking about A C1 B dash. Now focus to the image A C1 B dash. This is your object A dash B dash. Sorry, the bottom one equals to A dash and here it is equals to B dash. Now A dash B dash making an angle alpha. Okay, what is the alpha angle? A dash B dash is the angle made by the object. Okay, this is equals to alpha. Okay, so by the theory, A dash C2 C1 B dash equals to alpha on the left side. Rays coming from the final image at infinity and make A dash C2 B dash. Okay, here A dash C2 B dash making an angle beta. Clear? On C2. Yes, A dash C2 B dash equals to beta. Clear? So two angles we have, A alpha and beta. Now as the angles are very small, so beta can be treated as 10 beta, alpha can be treated as 10 alpha. Now you can write here 10 beta and 10 alpha. What is 10 beta is equal to perpendicular upon base. It is equals to A dash B dash upon C2 B dash. And what is alpha? 10 alpha A dash B dash upon C1 B dash. Now by dividing both of them, A dash B dash and A dash B dash getting cancelled, and it will be equals to C2 B dash upon C1 B dash upon C2 B dash. Clear? No, this whole A dash B dash is cancelled with A dash B dash. Okay, because a 10 beta upon 10 alpha equals to A dash B dash upon C2 B dash. Now this division convert into the multiplication and the lower part become upside C1 B dash divided by A dash B dash. Now both A dash B dash getting cancelled out and you will have C1 B dash upon C2 B dash. Clear or not? Now, what is C1B dash? C1B dash is the focal length for the objective lens. You see, your image is formed on the focal plane. So, C1B dash is equals to FO. Clear or not? And C2B dash equals to FE. Okay? So this is equals to FO upon FE. Now FO is positive and FE is negative. So for magnifying power for normal adjustment is equals to FO upon minus FE. Clear or not clear? So it is equals to minus of FO upon FE. So you can write M infinity is equals to minus of FO by FE. Negative sign of M indicates that the final image is inverted. Now length of the telescope, all total length, see the distance between the two lenses. What are the distance? Up to here it is equals to FO, right? And up to here it is equals to FE. And this is the distance between the two lenses. Obviously the tube will lying up to here. So L equal to FO plus FE. Agree? So length of the tube in this case for normal adjustment equals to FO plus FE. Okay. So clearly here to increase the magnification power, you have to reduce the focal length of the eyepiece and increase the focal length of the objective lens. Thus to increase magnifying power of an astronomical telescope in normal adjustment, focal length of the objective lens should be larger and focal length of the eye lens should be smaller. Clear? In normal adjustment of the telescope, the distance between the objective lens and eye lens equals to FO plus FE. That is the length of the tube. Clear? L equals to FO plus FE. So done. This is for normal adjustment. We have seen M equals to FO upon FE. Okay? So, FO upon FE. This is the condition for minimum magnification. Yes. Normal adjustment is called minimum magnification. This name is, another name is normal adjustment. Clear? Adjustment. Now, for maximum magnification, see the case for maximum magnification. When the final image is formed at a least distance of distinct vision D from the eye, same diagram is there. Magnifying power of the astronomical telescope can be defined as the ratio of the angle subtended by the eye on the eye by the final image at the LDDV, least distance of distinct vision, to the angle subtended by the object when the object is infinity, when it is seen directly. Okay, so this angle is equals to alpha. This also has to be alpha. Now your object is lying between the eyepiece and the image made by the objective lens. This is A dash B dash is lying between the focus and optical center of the eye lens, so it will give you a virtual image, rected image of the A dash B dash, and that will be formed at least distance of distinct vision D. Clear? Okay, so as the object is very far away from C1 and C2, close by, the angle subtended by the object and eyepiece are almost very small, so this equals to alpha, beta, and C2 B double dash equals to D. Magnifying power equals to beta upon alpha. You can consider it equal to 10 beta upon 10 alpha. Now place the value 10 beta is equals to A dash B dash perpendicular upon base equals to C2 B dash. Yes, this is equals to C2 B dash. Yes or no? This is equals to C2 B dash. Okay. Now this is for 10 alpha. Now for 10 beta is equals to perpendicular upon 10 alpha. C2 B dash is for 10 beta. So this angle is beta. So C2 B dash is base and perpendicular becomes A double dash B double dash. Clear or not? And for alpha, perpendicular becomes A dash B dash and distance equals to C1 B dash. So 10 alpha is equals to A dash B dash upon C1 B dash. Clear? So placing here the value A dash B dash upon C1 B dash. Now just divide them. Oh, okay. So 10 beta is equals to. Now check here. Instead of getting the value 10 beta by the big one triangle, I can use this one. The concept of similarity. 10 beta is equals to perpendicular A dash B dash upon base equals to C to B dash. Yes or no? Same angle it will give because it is similar triangle to the bigger one. Yes or no? So A2 here put the value equals to 10 alpha, 10 beta equals to A dash B dash upon C to B dash. Now A dash B dash getting cancelled out and here it is equals to C1 B dash upon C2 B dash. Clear or not clear? What is C1 B dash? It is equals to focal length of the objective lens towards rightward, so it will be positive. And C2 B dash is what? This will be equals to minus of UE. Yes or no? So this becomes FO upon minus UE. Clear? So magnification becomes M equals to FO upon minus of UE. Okay? So it becomes FO upon minus UE, where FO is the focal length of the objective lens and UE is the distance of object A dash B dash acting as an object for the eye lens. Now take the condition for eye lens. 1 upon FE equals to 1 upon VE minus 1 upon UE. So 1 upon FE equals to 1 upon V minus 1 upon U. Clear or not clear? Multiplied by FO. Okay, multiply it with by FO. So you will have FO upon FE equals to FO upon V minus 1 upon FO upon FO upon U. Clear or not clear? So you have placed it multiplied with FO. Okay, wait. Do not multiply it with by FO. Better, it would be better. You find the value of minus 1 upon UE. To find that, you place the value here like this. 1 upon V minus 1 upon U equals to 1 upon F. So place the value here. For V, here it is equals to minus D. Clear? So 1 upon V minus 1 upon U is equals to 1 upon F. So for eyepiece, V is equals to final image equals to at a distance minus D. Here 1 upon minus UE and here this is equals to 1 upon FE. Focal length of convex lens is positive. Now minus minus become positive. So 1 upon minus D. Find the value of 1 upon UE. So 1 upon UE equals to 1 upon FE up plus 1 upon D. Clear? You will have the value 1 upon U equals to 1 upon FE plus 1 upon D. Okay. What is magnification? Magnification you have equals to FO upon minus UE. You can write FM is equals to minus FO into 1 upon UE. Okay. You can write like this magnification value. Okay. Now the value of 1 upon UE you have equals to 1 upon FE plus 1 upon D. So place it here. So this is equals to minus FO 1 upon FE plus 1 upon D. Clear? If you take FE from denominator as a common, so M is equals to minus FO, take common FE. So it will become here only 1 divided by 1, so equals to 1. But you have taken common, but no FE is there, so make the numerator as FE, okay, upon D. So this is equals to final derivation minus FO upon FE 1 plus FE by D. Clear? Minus FO by FE. Here we have the formula M equals to FO upon minus UE, right? So make this minus sign upside. So FO into 1 upon UE. And you have placed here the value of 1 upon UE. That is equals to this one. Clear? So 2, 3 lines skipped are here. So negative sign of the magnifying power indicates that the final image of the telescope is inverted and length of the telescope equals to, in this case, the length of the telescope will be FO plus UE. Obviously, clear? Here in this case equals to FO plus UE because this distance equals to FO and this distance become UE. So the length of the tube will equals to FO plus UE. Fine. So length of the telescope becomes FO plus UE. Yes, for large magnifying power, FO must be as large as possible because FO is lying on the numerator. So FO must be as large as possible and FE must be as small as possible. Hence, in the telescope, aperture of the objective lens made larger to increase the magnifying power and resolving power of the telescope. Resolving power not in our syllabus, so no worry. So minimum magnification is given by M minimum is equals to minus FO upon FE. That is called normal adjustment, and maximum magnification is given by minus FO upon FE 1 plus FE by D. Got it? So yes, no, this is not resolving power. Resolving power is not in our syllabus, students. Okay, so this is for the derivation for the when your final image is at least distance of distinct vision. Okay, maximum magnification. Okay, two type of magnifications are there. Yes, first minimum magnification, this is equals to FO upon FE, and maximum magnification is equals to given by this FO upon FE 1 plus FE by D. Clear? A negative sign will be there also. Okay. So three formulas related to the magnification here for the our astronomical telescope. Make them first what? M is equals to FO upon UE. This is first formula. Clear? Then M infinite equals to FO upon FE. FO upon FE. Clear? This is for infinite. And this is M at least distance of distinct vision minus FO upon FE 1 plus FE by D. Clear? Three formulas. So this has been completed.